So welcome to the San Francisco MySQL meetup. We always start with announcements. One of the announcements I have, Oracle's community leader, David Stokes, has reached out to me, and he's asked if anybody wants to do a lightning talk at Oracle World. It allows you to get into all the BOFs and the various, kind of cheap things that Oracle does, which are still pretty darn good. And a lightning talk there is a little different than it is at the Percona conference. There are no slides, but you can bring props, sound effects, whatever. If you want to do a lightning talk, generally they're funny, and mostly on tech, but not always. I don't know how many of you all have seen lightning talks, but they're really fun to give, and they're fun to be part of. So if you want to do one for Oracle World, do you know what night, Giuseppe, they're doing it? The lightning talks?
I should be doing the community reception.
Which is the 29th?
It should be on Tuesday.
On Tuesday at the community reception is when they're doing the lightning talks. So hit me up, send me email, even if you're slightly interested. They could be really fun. They're not very intimidating. It can get your feet wet with public speaking. And then does anybody else have an announcement they'd like to make for the group? Jobs, looking for jobs, a fun project. Okay, then I'm going to move on. So tonight we have Giuseppe. Those of you who've been coming for a number of years knows that Giuseppe is our replication expert, and he's also our MySQL sandbox expert. And so tonight he's going to speak on replication, and it's actually I don't know about you, but I've been waiting to have replication that goes to NoSQL solutions, and now it's done. And Giuseppe's going to talk about it, and if he does like he always does, which I suspect he will demonstrate it. So.
Thank you.
I'll leave it to Giuseppe.
So good afternoon, good evening, everybody. Who uses MySQL here? Everybody good. Who uses MySQL and replication? Who has ever tried to replicate to something that is not MySQL? From MySQL to Oracle to MongoDB to Hadoop, SQLite, EOCAT, whatever. Anybody? Okay. Today I will tell you how. So for the ones who don't know me, can you hear me actually? Okay. So my name is Giuseppe Magia. I'm also called a data charmer. I have a data charmer blog. I've been in the MySQL community for a long time, almost the last century. And I am an Oracle ACE director, which means not that I'm an Oracle employee, because I'm not an Oracle employee. I'm employee of Continuent. But it means that I am a good community member of the Oracle community and MySQL community specifically. And so I have this title that tells everybody that I can be trusted. Don't do that, but listen to what I say and try this at home. I'm data charmer on Twitter, so you can send me questions, comments, anything. So today we are going to talk about Tungsten Replicator, which is the thing that will eventually replicate it to anything. We will touch on several topics related to heterogeneous replication. And then I will show you in practice this kind of replication and how to do your own replication. So the company I work for is Continuent. We have one product that is called Continuent Tungsten, and does two kind of things, replication and clustering. One of those is open source, and is the thing that we talk about today. And one of those is commercial. but the commercial product is based on the open source product. We have a bunch of customers. You may know some of those in the slide. People trust us for the replication and clustering solutions. So when we talk about continuity, usually my boss and other people show this slide and say how good and successful we are. And so this is the formal way of introducing continuant. I personally think that our team could be described much better this way. We are the superheroes of replication just because we do things that the normal powers of humans cannot reach. So let's see briefly what we are talking about today. Replicator, it's an external tool that you put on top of your database, and you can achieve replication. And you can replicate from MySQL to MySQL, from MySQL to Oracle, from Oracle to anything. It's familiarly called the golden gate without the price tag. And this is 100% open source, is released under the GPL v2. And you can download, play with the code, fork it, anything. So how does it work? If you're not familiar with MySQL replication or Oracle replication, let me tell you that whenever you are trying to replicate something, you have a database that will log changes somewhere. For example, in MySQL, there is a place that is called binary logs. In Oracle, there is a thing that is called change data capture. What Tungsten does, takes these logs, transforms those logs into something that is more elaborated and powerful, and then shares this kind of logs with other nodes and achieves replication. So in our case, we have the DBMS logs. These are then taken to the replicator and transformed into a thing that is called THL, transaction history logs. Once we have these transaction history logs, we can do mostly anything. So these transaction history logs, they go to the other nodes, for example, the slaves in this topology, and then they are converted back into transactions for the database where we want to apply. The design is very modular. Inside every step where we take the data from the database to the THL, from the THL to another node, from the other node to the database, we can apply filters, and we can modify to do operations in parallel. So we can do things that a regular replication cannot do. So we can apply to MySQL or to Oracle in several parallel streams and achieve not only good replication, but good replication fast. This is what we can do with Tungsten Replicator. We can do regular master-slave. We can do fan-in slave, which is the opposite. So fan-in slave means many master, one slave. We can do all masters, where every node is a master. We can do star topologies. And then we can do heterogeneous. So this slide is a few months old, so I prepared another one that is more comprehensive. So we have the regular, let's say regular, is something that only Tungsten can do, but we call it regular because it has been around for a long time. MySQL to Oracle, Oracle to MySQL, Oracle to Oracle, which is, things that we give to our customers on a daily basis. Then we have MySQL to MongoDB, which is to the applier to Oracle. It's something that we did during a conference as a proof of concept, and then we made it permanent. And we have MySQL to Vertica. Vertica is a data warehouse, a commercial data warehouse, where we can send data from MySQL. And we have very recently introduced MySQL to Hadoop. Just this month has become available MySQL to Redshift, which is a data warehouse from Amazon. And then we have something that is not very popular, but is there, and I'm going to explain what it is. We have a generic applier, meaning that we apply to something that is not a specific database. And using this not specific database, I made today something that can apply to SQLite. Not because there is much demand for that, just to show that we can. And whenever we talk about MySQL applying to MongoDB, Vertica, and so on, we can do the same with Oracle, because we can extract data from both Oracle and MySQL and apply to all these things. And using these recipes, you can create today your own applier and apply to anything. I will show you an example. So data warehouse loading that we have today, we can load very fast data from MySQL to Oracle, Hadoop, and Vertica. For Oracle, we have a dedicated applier, meaning that we get data from the THL and we apply directly to Oracle using an applier that we wrote. For Vertica and Hadoop, we have something different. We have the data that is sent to an intermediate storage in CSV files, and from that, it's applied to Vertica or to. The traditional approach to send data to data warehouse is very painful. If you have ever done that, you know that you need to extract the data from the original database, for example, MySQL. You have to transfer, and then you have to load into the data warehouse tables. This is something that is slow and sometimes is error prone. So many people are looking for solutions to avoid this kind of work, because it's really, really time consuming. So what we do instead of converting data and loading all at once, we do data replication runtime, meaning that as soon as the data changes in your database, you can move it almost instantly to Oracle, to Hadoop, to Vertica, or to whatever you decide that you need the data. So for Oracle, it's very simple. We just have an extractor in the MySQL side and an applier on the Oracle side. This is there is very little to see from the user point of view. You just have to trust the system, install it if you need help with it, and then it runs. There are many people using it on the open source, and many customers that are using it with our assistance. For Hadoop, the system is a bit different. The data goes from MySQL into a buffered transaction storage. It's something that makes the operations much more efficient. Also because if you have ever worked with Hadoop, you know that you cannot send one record from one place to another. You need to do batch operations. So sending one record is very much inefficient. Using buffer transaction becomes very fast instead. So what we do, we use an intermediate storage in the shape of CSV files. We create CSV files with the transactions, and I'm going to show you some examples. So we decide what is the field separator, what is the record separator, and what kind of fields are needed to do good replication. And we transform the THL into this intermediate storage. So what happens? We get the transaction from the master, and it goes to the Hadoop replicator. In the Hadoop replicator, there is a JavaScript application, let's call it, that will process the CSV files and then create staging tables. The staging tables are the things that Hadoop will then process in materialized views, which is a Hadoop way of processing data very fast. So what we do in this replicator is prepare the data to be replicated not record by record, but in large amounts. This is called batch applier. And please remember this, because we are going to see this, the same trick in other appliers. If you are interested into Hadoop replication, there is an Oracle Open World session for the ones who are registered for that. On Thursday, MC Brown, one of my colleagues, who is we call it the man who knows everything, because he's a walking encyclopedia, and is the director of documentation in my company. And he will talk in detail about replicating from MySQL to Oracle and Hadoop. Now, you want to load, instead to Hadoop, you want to load to Vertica, which I said is another data warehouse. What do? You have the build logs in MySQL, and they go to a buffer transactions. And from the buffer transaction, they go to Vertica. The system is similar to what we have seen for Hadoop. We have the data that goes from MySQL to the Vertica replicator. It goes into CSV files, and from CSV files is processed in a batch into Vertica. And remember this as well. This is the pattern that will allow you to do your own replicator. This month, we have something new also. Tungsten now supports Amazon Redshift. What is Amazon Redshift? Is another data warehouse owned by Amazon, where, if you are working in the cloud, it makes sense to use it. There are customers who want it, and we did it. So what do? We do mostly the same thing. So we take the data from MySQL. We go into the replicator for Redshift. There is a JavaScript application that will do something with the CSV files in a batch applier. We'll store these CSV files in S3, which is the storage for Amazon. And from there, they will be processed by Redshift very fast into staging tables and then tables. remember this is a pattern. So the data comes from the replicator, goes into CSV files, and then is transferred into something different. Any questions so far? One thing that I want to mention, there is a tool that we have created to make things easier when you are working with heterogeneous replication. You know, if you are using a relational database, your data goes into tables, and the tables are created according to a particular SQL dialect. So the dialect spoken by MySQL is different from the dialect spoken by Oracle, and spoken by Vertica, and spoken by Hadoop. So once you have your data in Oracle, if you want to transfer to MySQL, you need to convert those tables to the particular dialect. So we have a tool that is called DDL scan. I'm not going to describe in detail what it does, but I'm just telling you that you take the format in MySQL and you get Oracle tables, or you take the description of a table in Oracle and you get MySQL or Hadoop tables, whatever you need. So we have recipes to transform from one to another using DDL scan. Now, let me show you first demo. So we are going to see two things: how to transfer data from MySQL to MongoDB, and how to set up replication from MySQL to Hadoop. Okay, so the first thing that I have here in my Mac, I'm going to do replication in the same host. So I use Tungsten Sandbox. And I will create one master that has MySQL and one slave that has MongoDB. And while this is installing, which will be very fast, we go to one virtual machine where I have MySQL on Ubuntu, and another virtual machine where we have one very simple Hadoop installation. Since I have everything here, I don't trust the internet connection for this demo. So this will be a very simple Hadoop cluster, only one node, but it does what it needs to do. I have the installation program where I install the master first, and the thing that I have to do is say that I want to set the master for heterogeneous replication. So I tell the master to do a lot of transformations that will allow the slave to recognize what the data is. And then I will install the slave, which is Hadoop, and I just tell Hadoop to accept the data that comes from this particular node. Just set 50 lines of code, which are 3 commands, and with this we set replication. Everything that is done here is described in detail in the documentation. So we just run this, and let's see how it fails, or no, maybe not. Let's see what happened in the meantime for the MongoDB installation that we have done. So here we have 3 nodes. One is the master, one is a slave that is MySQL, and one is the slave that is MongoDB. Let's see. How does it work? We can go to MySQL and create a table. And then we can insert one record. And we have this data. Let's insert another record. And say test 2, and one more record, 3, test 3, and select star from T1. Now, if we go to the to the slave, which is MySQL, no surprises, we have the same data. But we also have MongoDB. So MongoDB show databases. And here you can see that we have a database test. Use test, show collections, which is the way that MongoDB describes tables. And then we do db t1 find. And we have the same data that we have seen in MySQL. Try to do something different in MySQL. So we do update T1 set message equals hello, where the ID is select star from T1 happens into MongoDB. We do the same. Instead of test2, here we have hello. So this is replication runtime. Not only we transfer data, but we transfer transactions. We transfer changes. And this means that our replication is effective. We not only send blindly data, but we also send meaning. Okay, so this was an easy thing with MongoDB. I'm going to destroy this because we need more things. And in the meantime, let's see what happened to our MySQL to Hadoop. So the command that I sent before has created one master, which is regular MySQL on Ubuntu, and one slave, which is Hadoop in CentOS. With Hadoop, we have a slightly longer process. So as I showed you in the slides, not only we need to transfer the data to Hadoop, we need also to process it. because the data will go to Hadoop in the shape of CSV files, and then Hadoop needs to elaborate that to convert the data into tables. So I have a script that I'm going to use now to create a table, populate it, and send it to Hadoop using all the process that we usually do. And this will take a few minutes to complete. So this is the data that is in MySQL. Now the script is waiting until the slave signals that it has received transaction number 12. At the moment we have number 2. After a while, when transaction has been received, then the data is converted into CSV. And this is the content of the CSV files. So this is the intermediate CSV file that contains the data for for Hadoop has been slightly modified in the screen just to show how it looks like. So instead of having the nicely looking output that we see for MySQL, we have just data separated by pipes. In reality, it's separated by character 01, which is not readable by humans, but I made a slight trick to show this on screen. So this is the data that Hadoop takes as a start, and then it will process the data and convert it into stage tables. The stage tables have the same data that you see in the CSV. And the important thing that you can see is here. The first column in the CSV is an instruction column. It says I, for example, that means insert, or it says D, that means delete. So when we have update, for the update we transform the update into a first delete for that record and then an insert for the new record. So you see here a delete followed by an insert, and you see that these two instructions have the same code. This is number 8 and this is number 8, meaning that this is the same transaction. At the end of the operation, you will see that the count in the tables in Hadoop, they match the count that we had in MySQL. So we have had a successful transaction. This is much slower than what we have for MongoDB, because in MongoDB we just send one record, we process the record immediately. In Hadoop we cannot do that. In Hadoop we process something like a million records at a time, and so it is going to be very slow also because this is a laptop that is using virtual machines. It has to be slow because I cannot give more than 2 gigabytes to that virtual machine, but it's working. In real time, in the real world, we have clusters of Hadoop with hundreds of nodes that will process this kind of records very fast. And actually, we can process records in parallel instead of doing everything in one flow like I did in this. But it's just to show you that we can do it. Now, back to the presentation. So we have seen two simple things. MySQL to MongoDB, which is a native applier. MySQL to Hadoop, which is a composite applier. First, the data goes to CSV files, and then using a combination of Replicator plus Hadoop, we get the data into the final database. So let's talk about this generic applier. Generic applier means that we send to a file or a set of files where the data is created according to the parameters that we set when we install. So you must remember this scheme that I mentioned when we were describing Hadoop, Redshift, and Vertica. All three of them use the same principle. There is a replicator that creates CSV files, and from the CSV files, we do something, which means to take the data and look at the operation that is in front and say, oh, this is an insert, let me create an insert. This is a delete, let's create a delete, and so on. So what we do in this case, we have in the master a simple table where we have one ID and some text and a timestamp. We put some into the table, and you see we have 3 records, and then we have an update. So first we create 3 records, then we say change the data in record number 2. Simple operation that many replicators today cannot do. So what do we have at the end? We have in the table where the second record has the final data that we put in the update, and the rest is what we entered during the insert. What happens on the other side, in the slave, which in this case is just a generic applier, meaning that we have, as a result, only a CSV file. In the CSV file, we have this. We have the first line, that is the list of information about the columns. So you just have the description of the record. So we have tungsten opcode. What is the opcode? Is the operation that we need to do. So for the first 3 records, we have 3 insert, I. And then we have the sequence number, which is the number of the transaction that was inserted. The row ID, the timestamp, and we have the data that belongs to the table itself. So everything that we replicate has this structure. First, 4 columns that are the same for every table, and then we have different information depending on which table we are replicating. Now for the last update, instead of having 1 line, we have 2. The first line is a delete that says delete the record that has ID number 2. And then there is an insert, which insert with the same ID. But we change the data. How do we achieve this? Using the installer, we just say for the master, enable batch master. What does it mean? It means that the master gives extra information to the THL so that the slaves can process that information and do things that a regular replication between MySQL and MySQL cannot do. And then we say enable the schema change filter, which is a log, a special log that will log all the DDL information in a file and in some other places. And this allows us to do something with this DDL if we want. Either we use the DDL scan that we said before, or we use the information in the schema change to take the DDL information and do something in the final database for our needs. In the slave, we have to say something similar. We have to say that we are using the batch applier, and we have to say which JavaScript file we are using to process this. Now, we have a special JavaScript that is called do nothing. It doesn't do nothing. It just takes one code and puts that in a specific place. This do nothing will just create a CSV and nothing else. So compared to the thing that we have in Hadoop where we create the CSV and then we process it, this do nothing will just create a CSV for you to see. In addition to that, we can say how do we want this CSV. For example, we can say the field separator that we want headers. For example, in Hadoop, we don't use headers. And what kind of CSV we want, and so on. So we can just be very demanding about what we want. If we want to do all these things together, we just use in the Tungsten sandbox that we have seen before for MongoDB. Instead of doing replication to MongoDB, we do replication to the file applier and then create CSVs. Let's have a look. So instead of topology equals MongoDB, we say file applier. Any questions so far? While this is working? Yes, please. So the question is, how do we manage to do things at scale when we are using this kind of replication? Basically, it's in the design. So replication just happens using the THL. And we have customers that are moving hundreds of terabytes of data using this system. So it simply works. The replicator has been designed in such a way that it can handle a lot of data at once. So if you have many nodes, you can split them into clusters, or you can use several topologies to play with them. So let's see what happens here when we do the same thing that we have done before. We have no tables. We create a table. We insert the data. And we insert one more record. So on the other side, we don't have a table now. And let's see what we have instead. We have two CSV files that will have our information. You see the first one has the first record, and then the second one has the second record. So this is the generic applier that I was telling you before. It will simply create a CSV, which at the moment is not extremely useful, but let's remove this. Each transaction gets its own CSV file, but you know the transaction can have 10,000 records. So the thing that you need to do after that is to use this CSV file for something more useful than a simple CSV or a simple set of CSV. So let's now create something more interesting. We have a similar way to create SQLite. Now, how do we do that? We use the CSV to process the data into SQLite. So we read the data, we evaluate, is there a destination table in SQLite? If no, we just get a data structure from MySQL master, create the table, and return to read the data. Then, is there a destination table? Yes. So, is the operation an I? If yes, we add an insert to the buffer. What is the buffer? It's just a set of operations that we are going to send to SQLite. If no, we check, is the operation a delete? If yes, we add delete to the buffer. No, we generate an error because we don't know what to do if the operator is not I or D. Then we check the transaction count. So we decide how many records we want to apply to SQLite. You know, SQLite is very powerful, but if you insert one record at a time, it's going to be painfully slow. But if you insert, let's say, 5,000 records at once, then it's going to be very fast. So we say, create a buffer of 5,000 records before you do, actually, 5,000 transactions before you do something. When we reach the maximum transactions, then we commit into the database, and we start back reading from the CSV. So let's see how this works in practice. We have the same thing that we have seen before. We are going to do the same thing. Show tables, empty. Create a table, insert a record, insert another record, and insert another record. So if we look, we have CSV files like before, but now we are going to have also something different. We're going to have a test.db, which is a SQLite database. Actually, let's do that from another window. select star from T1. It works, okay. What do we do now? We do an update T1 set message equals San Francisco, where ID equals 3. I equals 3. Select star from T1. Now you see that record number 3 has San Francisco. Let's see what happens. SQLite. And you see that we have good replication, meaning that we don't have a duplicate. We have the record that has been modified according to what we needed. Now, allow me to do something foolish. I'm going to show you how to replicate to my reminders in my Mac. It's not much useful, but you know, it's kind of interesting. So I have a where I create a schema named reminders. I create a table named shopping San Francisco, and then I insert things into this table. So let's do it. I'm inserting from that table, and you see on the right, my reminders are just getting this. This is not extremely useful, but it's just to show you that using Tungsten Replicator and the infrastructure that is available for replicating, you can do mostly everything. So I said before in the beginning that you can replicate your cat. I don't know how to do it, but I'm sure that somebody will find a way. So with this, we can wrap up everything. You can find the code into tungstenreplicator.org, because this is open source. And Tungsten Sandbox is in Tungsten Toolbox, which is also open source. There are all the recipes to create the file applier, replicating to Hadoop, replicating to SQLite, and replicated to your cat. No, I'm joking. This is up to you. So the documentation, this is very important, is in docscontinent.com. And this is where you find all the description, step by step, how to set up replication to Hadoop and Vertica, Redshift, and so on. So you can replicate it to mostly anything. Please surprise me and show me tomorrow that you have replicated to something that I was not thinking about so far. We have a Twitter account, Continuent. You can let us know your thoughts, or you can ask questions there. And speaking of questions, is question time. Please. Can we replicate from Oracle to MongoDB? Yes. You can replicate from Oracle and from MySQL to anything that can be replicated to. So once you have the data into the THL, you can do whatever you want, including the reminders. Please. Do we extract from rack? Yes, we do. I don't know the details, but I have a couple of smart colleagues who figured out, and we have customers using it. Can we replicate data from or to Postgres? Yes, we can. We can, yes. Actually, you can, the same way that I have done replication to SQLite, you can replicate it to ODBC, and from ODBC or JDBC, you can replicate it to anything. Can you speak louder, please? So the question is, instead of using CSV files, if you can stream the data somewhere. Actually, this is what we do for Oracle and MongoDB, but it is a dedicated applier. So using CSV is a way of making a general purpose replication. We can do to something else. It depends on what you need to. So all these things have been developed because there were customers who were sponsoring that particular solution. So we have the CSV because somebody asked us to replicate into Vertica. So we say, how do we replicate into Vertica? We can say, we can do that using CSVs, and this is what we did. Then when somebody else said, we need replication to Hadoop, I say, oh, we can use the same thing plus some more tricks to replicate into Hadoop. And using the same thing, we did Redshift. And using the same principle, I did SQLite. Yes, we can certainly do a different approach, but it takes more time. If you have ideas on how to do a streaming replication that is general purpose, feel free to comment on our mailing list. Actually, if you want to implement it, it would be even better. More questions? Okay, thank you. I hope you enjoyed it.
So you're going to give me your slides, aren't you?
You want the slides?
Yeah, we put them up.
Okay.
So I'll bug you. But your job is not done.